In the vast expanse of our universe, there lies a star that has captivated the attention of astronomers and stargazers alike, Betelgeuse. This star, with its mesmerizing glow and intriguing characteristics, has been a subject of fascination for centuries. Its name, derived from the Arabic phrase Yad al-Jawza, meaning the hand of Orion, hints at its prominent position in the night sky. This celestial giant, residing approximately 724 light-years away from our humble planet, is not just any star. It is one of the most studied and observed stars in the universe, providing invaluable insights into stellar evolution and the life cycles of stars. Betelgeuse is a red supergiant star located in the constellation Orion. This constellation, often referred to as the Hunter, is one of the most recognizable patterns in the night sky, and Betelgeuse marks the Hunter's shoulder. Its distinct reddish hue makes it stand out among the other stars in Orion. Betelgeuse is truly a behemoth, with a radius roughly 1,400 times larger than our own Sun. To put that into perspective, if Betelgeuse were placed at the center of our solar system, its outer surface would extend beyond the orbit of Jupiter, engulfing all the inner planets, including Mars. This immense size is a testament to the star's advanced stage in its life cycle. As stars like Betelgeuse age, they expand and cool, becoming red supergiants. This transformation is a natural part of a star's evolution, driven by the complex processes occurring in its core. What makes Betelgeuse even more fascinating is its visibility to the naked eye. Despite being so far away, its sheer size and brightness allow it to be seen without the aid of telescopes. This has made it a favorite among amateur astronomers and stargazers. It shines brightly in the night sky, appearing as a prominent reddish star in Orion's shoulder. This distinctive color is due to its cooler surface temperature compared to other stars, which gives it a reddish-orange hue. Its luminosity is over 100,000 times that of our Sun, making it one of the most intrinsically bright stars visible from Earth. This incredible brightness is a result of its massive size and the energy it emits as it burns through its nuclear fuel. This immense size and brilliance are indicative of a star nearing the end of its life. As Betelgeuse continues to burn through its fuel, it will eventually reach a point where it can no longer sustain the nuclear reactions in its core. Betelgeuse is classified as a red supergiant, which means it has already exhausted the hydrogen fuel in its core and has expanded significantly. This stage in a star's life is marked by dramatic changes, including increased luminosity and size. As it continues to evolve, it will eventually exhaust its remaining fuel, leading to a spectacular cosmic event, a supernova explosion. This explosion will be one of the most powerful events in the universe, releasing an enormous amount of energy and light. This makes Betelgeuse a prime candidate for observation, as its eventual demise will be visible from Earth even during daylight hours. The supernova will outshine all other stars in the night sky, providing a rare and awe-inspiring spectacle for astronomers and the general public alike. In late 2019, astronomers noticed something peculiar about Betelgeuse. The star, normally known for its consistent brightness, had begun to dim dramatically. This unexpected event, dubbed the Great Dimming, sent ripples of excitement and speculation through the scientific community. Over the next few months, Betelgeuse continued to fade, reaching a minimum brightness in early 2020 that was significantly lower than anything observed before. The Great Dimming of Betelgeuse sparked intense debate and speculation among astronomers. Was this a sign that the star was about to explode as a supernova, a long-awaited event that would illuminate our night sky for weeks? Or were there other, less dramatic explanations for this unusual behavior? Initial theories focused on the possibility of a massive dust cloud obscuring our view of Betelgeuse. Dust clouds are a common sight in space, remnants of previous stellar explosions. These clouds, often referred to as interstellar dust, are composed of tiny particles of carbon, silicon, oxygen, and other elements. They float through the vast expanse of space, sometimes coalescing into larger structures. Over time, these dust clouds can form intricate and beautiful patterns, illuminated by the light of nearby stars. These regions, known as nebulae, are the birthplaces of new stars. Within these nebulae, gravity pulls the dust and gas together, creating dense regions that eventually ignite to form new stars. The process is both violent and beautiful, as the energy released by the forming stars illuminates the surrounding dust, creating stunning cosmic vistas. These clouds, composed of tiny particles of dust and gas, can absorb and scatter starlight, causing stars to appear dimmer when viewed from Earth. This phenomenon, known as interstellar extinction, can make it challenging for astronomers to study distant stars and galaxies. The dust can obscure our view, making it seem as though the stars are less bright than they actually are. In the case of Betelgeuse, it was plausible that a large dust cloud had moved into our line of sight, temporarily dimming the star's light. Betelgeuse, a red supergiant star in the Orion constellation, has long fascinated astronomers due to its variability and potential to go supernova. The sudden dimming of Betelgeuse in late 2019 and early 2020 sparked intense interest and speculation within the scientific community. This theory was further supported by observations of Betelgeuse in infrared wavelengths. Infrared telescopes, such as the Spitzer Space Telescope, are capable of peering through dust clouds that would otherwise obscure our view in visible light. These observations provide crucial data that can help astronomers understand the behavior and characteristics of stars like Betelgeuse. Infrared light, unlike visible light, can penetrate dust clouds more easily. This allows astronomers to see through the dust and get a clearer view of the stars and other celestial objects hidden within. By comparing visible and infrared observations, scientists can gain insights into the composition and distribution of interstellar dust. If a dust cloud were responsible for the dimming, then Betelgeuse should have appeared brighter in infrared observations. And indeed, infrared data showed that Betelgeuse was not as dim in these wavelengths, supporting the idea that dust was playing a role in the observed dimming, and indeed that is exactly what astronomers found. The infrared observations confirmed that while Betelgeuse appeared dimmer in visible light, it was still relatively bright in the infrared spectrum. This provided strong evidence that a dust cloud was at least partially responsible for the dimming. However, while the dust cloud theory seemed like a plausible explanation, it didn't quite explain the extent of the dimming observed. The degree to which Betelgeuse had dimmed was far more significant than what could be accounted for by a typical dust cloud alone. This discrepancy left astronomers puzzled and searching for additional explanations. Betelgeuse had dimmed far more drastically than could be accounted for by a typical dust cloud alone. The star's brightness had dropped by an unprecedented amount, leading some to speculate that other factors might be at play. This dramatic dimming event was unlike anything previously observed in Betelgeuse's long history of variability. This led scientists to explore alternative explanations, and soon a new and even more intriguing hypothesis emerged. Some researchers began to consider the possibility that Betelgeuse might be undergoing significant internal changes, potentially related to its advanced stage of stellar evolution. The mystery of Betelgeuse's dimming continues to captivate astronomers as they seek to unravel the secrets of this enigmatic star. Section 4. Enter Betelbuddy, a companion star emerges. In 2024, a team of astronomers led by Jared Goldberg proposed a new and exciting hypothesis to explain the great dimming of Betelgeuse, the presence of a companion star nicknamed Betelbuddy. This companion star, according to their research, could be the missing piece of the puzzle explaining why Betelgeuse underwent such a dramatic dimming event. The Betelbuddy hypothesis is based on the idea that Betelgeuse is not alone in its corner of the cosmos, but is instead part of a binary star system. Binary stars are quite common in the universe, with many stars existing in pairs gravitationally bound to each other. These pairs often interact in complex ways, influencing each other's evolution and behavior. Section 5. Ori B. Unveiling the Betelbuddy's identity. Goldberg's team proposed that Betelgeuse's companion, potentially named Ori B, could be a star up to twice the mass of our Sun. This intriguing hypothesis emerged from detailed observations and complex simulations, which suggested that such a companion could have a significant impact on Betelgeuse's behavior and characteristics. This companion star, they suggested, might be orbiting Betelgeuse at a relatively close distance. The dynamics of this binary system could be quite complex, with gravitational interactions influencing both stars in ways that are still being explored by astronomers. The presence of Ori B could explain the Great Dimming in a rather unexpected way. The Great Dimming event, which puzzled scientists and stargazers alike, saw Betelgeuse's brightness drop dramatically, leading to numerous theories and speculations about its cause. Imagine Betelgeuse, a massive star constantly shedding material into space, creating a sort of stellar wind. This stellar wind consists of charged particles and gas, which are ejected from the star's outer layers at high speeds, forming a vast, expanding shell of material around the star. Now picture Ori B, the companion star, orbiting through this wind. As it moves through the dense material, it interacts with the stellar wind in ways that can create fascinating and complex patterns of movement and accumulation. As Ori B moves through Betelgeuse's outflowing material, it acts like a snowplow, pushing the material ahead of it. This interaction can lead to the formation of dense clumps of gas and dust, which are then carried along by Ori B's gravitational influence. This action creates a denser region of dust and gas in Ori B's wake. These dense regions can have a significant impact on the light we receive from Betelgeuse, as they can block or scatter the light, leading to variations in the star's observed brightness. When Ori B and its accompanying clump of dust moved into our line of sight, it could have caused the significant dimming observed during the Great Dimming event. This theory provides a plausible explanation for the sudden and dramatic decrease in Betelgeuse's brightness, which had left many astronomers searching for answers. This hypothesis elegantly explained both the severity of the dimming and its temporary nature. As the dense clump of material moved out of the line of sight, Betelgeuse's brightness would gradually return to its normal levels, resolving the mystery of the Great Dimming. As Ori B continued its orbit, it would eventually move out of our line of sight, allowing Betelgeuse to gradually return to its normal brightness. This cyclical interaction between the two stars could lead to periodic variations in Betelgeuse's brightness, providing a fascinating area of study for astronomers in the future.